Hi there, I'm Hao, and it is just another video of me solving random difficult problem. So we have the coin change problem today. We're given an integer array coin representing the coins of different denomination and an integer amount, representing a total amount of money. Okay, so this is our coins 125 and the amount of 11. So we need to return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, then return -1. So the best combination for 11 is 5, 5, and 1, right? Or we can do like 5, 2, 1, 2, so 8, 10, and 5. Oh, sorry, 7, 8, 10, and 1, right? This also equal to 11, but we want the fewest number of coins. The best solution is the fewest number of coins, which is 5, 5, 1. So the output is 3 here. Right? If we have the two coin and the amount is 3, right? There's no way to make up this amount, so we return -1. And if the amount is 0, right? Then we just return 0. Because we don't need any coins to make up 0 amount. Okay. So let's say we can start from 11, right? We start from 11 and we look at three coin, right? We either select 1, 2, or 5, so we have three options. So it is like a backtracking problem. Right? If we select 1, right, then we have 10 left. If we select 2, then we have 9 left. Select 5, right, we have 6 left, right, so on and so forth. So 10, we select 1, we have 9 left. We have 2, we have 8 left. 5, we have 5 left. So we have 1, 8, 2, 7, 5, 4. Select 1, we have 5. Select 2, we have 4. Select 5, we have 1. Right. So 9, we select 1, we have 8. Select 2, we have 7. Select 5, we have 4. 8, 7, 6, 3, 4, 3, and then 0. Right. So when we get to 0, right, that is one solution, right? So we just have to as we do the recursion, I will iterate out. Right. We just have to add up the number of coins. Just have to keep track the number of coins we have been used, right? So in this case, what is it? It says 1, 5, and then 5, right? So this one is 1, 5, and 5, right? So like three coins, three coins. Okay. Um. So simple here, right? We can look at one here, right? We can also have what if we select 1, we have 0, right? If we select 2, we have -1. We select 5, we have -4, right? So these twos are like invalid, right? Because it have the it is a negative number, so there's no way we can make up the amount by choosing this combination, right? But here we have another solution here, right? Which is this path 5, 5, oh sorry, 5, um, 5, 5, 5, and 1, right? So three coins. So 5, 5, 1. This is like 1, 5, 5. Right. So we need to find all possible combination, right? And take the minimum, the combination that have the fewest number of coins, right? So we just compare and take the smallest. in this case, they have the same number of coins, so it doesn't matter, right? If we reach an invalid combination, we have negative number, we just go ahead and return infinity. So it only pass the comparison, right? So we can compare 3, and infinity. So we're gonna have 3 as our result. And if in the end we have infinity for the amount, which means there's no way to make up that combination, so we can just go ahead and return -1. And yes, the um okay, let's look at 8 here. So we have 7, 6, and then 3, right? Okay, so what is the time complexity for this? So we have like 3 possible paths, right? 3 possible paths. So it will be 3 to the depth, right? So 3 here is the number of coins, right? Number of coins, and the number of paths is the amount, right? So in the worst case, we need to select the one coin 11 times. Right? So it would be 3 to the amount, right? And if we look carefully, we can see that there's a lot of repetition here, right? We have the subtree, they pretty much the same, right? If the amount is 8, um, then it will be repeating, right? So we can use memory, we can use a dynamic programming for this. We can set the value for each amount and just uh, return it when we reach that amount again, right? So let's say if we find the best amount, the fewest number of coins for $8 is like, let's say 2 coins, right? And when we reach the 8 again, we can just like return 2 instead of iterating to everything again. So this way, the maximum number of time we will reach each node is 2 times, right? So we can reduce the time complexity to m by n, right? Where m is the number of coins and the amount, n is the amount. Right, because we need to check like every combination, right, of the coin. So if we have like 11, like as the amount, right, we need to check the 11s, starting with 1, starting with 2, and starting with 3, right? So that's why it's like n times n. Okay. So let's go ahead and code this up. So we can have like a callback function, right? We can start out at amount, and we can return. And we're gonna have our dynamic programming memorization, right? So we can do minimum coin range, right? So minimum coin uh, is equal to that, right? And if the minimum coin is equal to infinity, we can return negative ones, otherwise we will return the minimum number of coins. And we can just realize calculation function here. So we can type in the amount, right? Total amount. Okay, so if the total amount is, as I said earlier, is less than 0, right? Or it's negative, we will want to return infinity. So it always pass the comparison. And if the current amount is 0, right, which means we found our solution. So you can just go ahead and return 0 here, right? And we can iterate over each coin, right? So coins for each coin. We want to call the dot function again, passing the remaining, right? So if we select coin 1, then the remaining would be 11, right? Current amount minus 1, which is 10, right? So current amount minus coin, right? It is the remaining if we were to select the current coin. like, and we need to plus one, right? So what is the plus one here? The plus one here is to count the the core that we are selected, right? So this backtracking, right, will either like return one, or return infinity or zero, right? So we can just add up the cores that we are selected, okay? And what do we want? We want the minimum, right? So instead of for each, we can do the map. So we can do map.min, right? To get the minimum, and we can set it to our memo of amount, of current amount, input to this, and we can return the memo current amount of yen, right? And if and if the current amount, right, is already in the memo, then we want to just return it directly to save some time. We don't need to do the backtracking again. Current amount, right? So the map here will return an array of minimum coins for the remaining amounts, right? So we can just select the minimum, the minimum combination, the combination that have the fewest coin, right, and step it into our memo. Okay, so let's give it a try. Okay, not a number. Current amount, starting from amount minus the coin, right? If it is less than zero, we return infinity. If it is zero, then we return zero, right? And if it is in the memo, we just return it directly. And we find the minimum combination before we return. Oh, yes, because coins is an array, right? So we need to spread it out, right? Math.min type in a comma parameters like this. And the map will return a new array. So we need to spread it out. Okay. Pass, submit, and work. Um, so using this approach, we were able to pass the test. However, because we are using recursion memorization, so we need to use the stack frame here, which is like not too good for the display complexity. So we can use the tabulation approach by going bottom up, right? So it is the top down approach. And instead we can go from the bottom up, right? That is also possible. So as you can see here, we are starting from the maximum amount, and we just keep decrementing the amount with the coin until we get to zero or negative, right? So now instead we can start from zero and go up to the amount, right? So we can have an array from like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So we can have an array from zero up to amount plus one, right? Up to amount, zero up to amount, right? So the length of the array is like amount plus one, right? And then this will represent our amount. And actually, this is our amount, uh, amount. It is our amount. Let me make some space here. Amount, right? Like we can have an array for it, right? So this array um can represent the best combination for the amount, right? And we can start out as infinity. So let's say in order to match the change for amount 0, right? Uh, this will represent the fewest number of coins that we need to make this change, right? For 0, we can just start out at 0 because we don't need any coins to make the change for amount 0, right? And we can go up to the amount, right? So let me delete this to get some space here. Okay, so every so we just have to iterate over the amount, right? We can start from 1 because 0 we don't need to do anything with 0. So if the amount is 1, can do this the coin, the coin, the coin. And we have 3 coins, right? So 1, 2, and 5. Okay, so we can find the difference, right? And we can look at the DP of 0, right? DP of -1 and DP of -4, right? So if it is negative, right, we're just gonna ignore. We just don't gonna ignore. We only look consider processing if the difference is is greater than or equal to 0, right? So the idea is that if we were to use coin 1, right, then we need to add 1 here. So the number 1 here will be to use this coin, right? This coin. The 1 here will be so we are counting the number of coins, right? So if we were to use coin 1, right, then we need to add 1, right? And then we can just look at the best possible combination to make up the remaining change, right? And because we're going from left to right, so whatever remaining will be on the left side, which we already built out here, right? So the best combination for amount 0 is 0, right? So this is just 1, right? So we can replace this with 1 and keep going, right, to the next amount. So we are building the amount from small to large, from the bottom up here, right? So similarly, now it would be 2 minus 1 is 1, and 2 minus 2 is 0, 2 minus 5 is -3. So we just ignore the last one, right? And then this one is dp of 0 plus 1, right? Okay, so dp of 1, hello? Yeah, okay, sorry. So TP of 1 is 1, right? And DP of 0 is 0. So the result would be 2 and 1, right? So we just take the minimum, which is 1. And we can put 1 here, 1 here. Okay. So let's load out here, right? So if we were the first row is coin 1, right? So if we were to use coin 1, right? If we were to use coin 1, then we need to add 1 to account for that coin, right? And whatever remains, right? So the amount is 2, and we use coin 1. So whatever uh remaining, which is 1, right? We can look at the best combination for the amount 1. So the amount 1, we already uh find out the best combination for 1. We already know it, right? From the previous iteration. So we just need to read it from the DP, right? So so if we want to build out the number 2, so the amount 2, we need two coins, right? The best we can do is 2 coins if we are using coin 1. But if we are using coin 2, right, then we only need 1 coin, right? So 1 here is for coin 2, and whatever is remaining is 0. We don't need any coins for 0 amount, right? we already built out that, so we can just with that. So one, right? So we just pick the minimum, which is one here, because we can just use coin number two, right? So similarly, we can just continue to do this until we got up to the amount 11, right? The our expected amount. So let me speed up here. So three, right? So three minus one is two. Three minus two is one. This is negative, so we just ignore, right? We plus one to account for the coin that we pick, right? Okay. So the first one is DP of two. If we use coin one, right? Then we just add one, and the best combination for amount two, the remaining, which is amount two, is one. So it is one. So the result is two. So DP at one. If we were to use coin with the coin two, right? We need to add one to account for that. And then whatever remaining is one. And what is the best combination for one? We already know it here, right? So which is one. So one plus one is two. In this case, they are equal, so we can just pick either one, right? So two. So it is four, right? Four minus one is three. Yeah, three here. And then four minus two is two. Four minus five is negative, so I ignore. Okay, so dp of three is two, right? Two plus one is three. dp of two is one. One plus one is two, right? So we can just pick the smaller one, right? Which is two coins. Two coins. Okay. So same for five. So five. This is zero, right? This is three. This is four. So this one will be the smallest, of course. dp of zero is zero. Plus one is one, right? We can just use one coin, which is coin five here. Because if we use coin five, then we have zero remaining, right? And the best combination for zero amount is zero coin. So uh, it is one here. Yeah. Right. Similarly, six, six. Um, it is five. It is four. It is one. dp of five is one. One plus one is two. dp of four is two plus one is three, right? dp of one is one. This one is two, right? So the best is two here, two, and so on and so forth, right? Okay. So let's code this up. So we can iterate through our amount, right? On one less than or equal to amount, right? And then amount plus, and then we will return something at the end. Okay, so we need our array, right? Our tabulation. Let's call it tab, or just like pp, equal to array of amount of one, because we start from zero, right? Plus one, we want to start out with infinity, right? So it's only past the first comparison. And we want to set uh the first one to the first coin to zero, the first amount to zero. So amount zero, we don't need any coins, right? And then we can iterate through every single coin. So let I equal to zero, less one, apply, plus plus. So if the uh, amount minus the coins that we chose, right, is greater than or equal to zero, then we process. If it is negative, we just ignore. Okay, so we can just take the minimum, right, of the dp at I, uh, and TP at TP at amount minus coins. Oh, sorry, TP at amount, right? And then TP at amount minus coins of I, plus one, I believe, plus one, and set it equal to the amount. Okay, and we can return the TP amount at the end. So if it is infinity, we select -1. Otherwise, we return the amount, uh, amount. Okay. So yes, so we plus one here, right? To account for the coin that we chose, right? And then we just look at the so this is one coin that we choose, and we look at the best combination for the difference, right? The amount minus coin I. Because we know that amount minus coin I will be greater than or equal to 0, right? So we can check the best combination that we already have, but we built out previously. And we compare that to what we currently have in the TP, right? And remember we start infinity, so it's only passed in the first step. All right, so let's give it a try here. Okay, time limit exceeded. What am I missing here? So we start off from the amount. We look at every course. Um, we update the amount. Math.min of dp at amount. And dp of amount minus core of I plus 1. Okay, I think it is the amount, right? Typo there. Let's try it again. Okay, accepted. And yeah, as you can see, the runtime is much faster, and we have much better space capacity because we don't have to use the close side. So thank you for watching.